A reduced fraction is a fraction where there are no other factors besides 1 that you can divide into the numerator and the denominator. So what you guys do is find the GCF of the numerator and the denominator, and you reduce them both by that value that you found. So find the GCF in your example here of each fraction and then write it in reduced form. So I know that every single pair of numbers has a common factor of 1, but when you use 1, you're not actually changing or reducing the fraction. So we're looking for the largest number the numerator and denominator have in common other than 1 that we can reduce this by. So if you look at 12 and 16, what's the largest number that 12 and 16 are both divisible by? And it's going to be 4. So that is what we're going to divide the fraction by. So numerator and denominator. So 12 divided by 4 will be 3. 16 divided by 4 will be 4. So 3/4 is the reduced version of this fraction. It is the same value. 12/16 is the same thing as 3/4. It's the same quantity, just simplified. So how about 3/9? What are 3 and 9 both divisible by? 3. So 3 divided by 3 is 1. 9 divided by 3 is 3. So that's GCF there. So 15/3, you guys could either already recognize that 15 divided by 3 just equals 5, or you can leave it as a fraction. It doesn't matter. But 15 and 3 are both divisible by 3. 15 divided by 3 is 5. 3 divided by 3 is 1. So you can leave it as 5/1, or just simply 5. Either one would be fine. 2 and 4/6. So when you guys are reducing, you only reduce the fraction part. So hopefully when you're looking at this, you recognize that 4 and 6 can both be divisible by 2. You only reduce the fraction part. So when I say that, what I mean is divide 4 by 2, get 2. 6 by 2, get 3. You don't want to divide the whole number. So you don't do 2 divided by 2 and get 1. That whole number just stays there. You're only reducing the fraction part of it. So the reduced version of 2 and 4/6 is just 2 and 2/3. You don't actually check or reduce that whole number by anything. It is already reduced, I guess, if you will. We're only checking the fraction part of it. So let's use the GCF to write these guys in reduced form. And if they need to be written as an improper fraction, we'll write them out as that. But I always reduce them first and then turn them into an improper fraction, because if you reduce them first, your improper fraction will just end up being reduced. So let's see, 4/18, 4/18. Both divisible by 2. So 4 divided by 2 is 2. 18 divided by 2 is 9. So 2/9. 20/8. They are both divisible by 2, but the greatest common factor is going to be 4. So divide by 4. 20 divided by 4 is 5. 8 divided by 4 is 2. And then we need to make this an improper, or I'm sorry, a mixed number. So 5 divided by 2 is 2.5. So 2 is our whole number. 2 times 2 is 4. So 5 minus 4 is 1/2. 2.5. So 5 and 2, 6. 2, 6 can be divisible by 2 there. Again, we just leave the 5, just bring him right down. But 2 divided by 2 is 1. 6 divided by 2 is 3. So 5 and a third will be our reduced answer there. 8 halves. So either just recognize that 8 divided by 2 is 4. Or you can say, well, the GCF here, they're both divisible by 2. So if you divide them by 2, 8 divided by 2 is 4. 2 divided by 2 is 1. There's nothing wrong with leaving your answer over 1 or just writing it as the number itself. They both mean the same thing. They're both equivalent. Excuse me. Let's go ahead and try H. I'm going to have you guys try the other two. So 14 fourths. Divide them both by 2. 14 divided by 4 is 7. 4 divided by 2 is 2. Let's write it as a mixed number. So 7 divided by 2 is 3.5. So 3 is our whole number. 2 times 3 is 6. So 7 minus 6 leaves us with 1/2 left. When you guys are reducing fractions, you can always go down in baby steps too. So I know we already did B. But say you guys didn't recognize that the GCF was 4, but you did recognize that it was even. So you said, okay, well, I can divide by 2. That would give me 20 divided by 10, or 20 divided by 2 is 10. 8 divided by 2 is 4. But then you're like looking at it and you're thinking, well, they're both still even. Okay, so you can divide again. Ideally, it is best to come up with the greatest common factor to reduce these fractions. But if you need to do it in steps, as long as you get to the reduced fraction, it's fine. So you can, by all means, divide by 2 again. 10 divided by 2 is 5. 4 divided by 2 is 2. So whether you divide by 4 or divide by 2 twice, you still get to the same result. And that's what's important. It's just making sure you're getting to that reduced answer. So then 5 divided by 2 is 2.5. So if it specifically asks for what the GCF is, like what we did up above, with identifying the GCF, then you need to know what the greatest common factor is. But with reducing fractions, yes, it would be great to always know what the largest common factor is, but ideally, you just need to get to the smallest and most simplest form of that fraction by dividing by common factors. If you come up with the greatest common factor first, great. Why don't you guys try E, F, and G?